Yes, good morning, my dear children. Today we continue our KEAM discussion of previous year. And today, as I told you in the last class, our unit 7, which includes electromagnetic waves, ray optics, wave optics, electron photons, photoelectric effect. ഇത്രയും ചാപ്റ്ററുകളാണ് നമ്മൾ യൂണിറ്റ് 7 ഉൾപ്പെടുത്തിയിട്ടുള്ളത്. ഒരിക്കൽ കൂടി അത് ഇലക്ട്രോമാഗ്നെറ്റിക് വേവ്, റേ ഓപ്റ്റിക്സ് ഉണ്ട്, വേവ് ഓപ്റ്റിക്സ് ഉണ്ട്, ഇലക്ട്രോൺസ് ഫോട്ടോൺസ്, ഇത്രയും ചാപ്റ്റേഴ്സ് കൂടിയതാണ് നമ്മുടെ യൂണിറ്റ് 7. Now we can straight away start with our questions. പലപ്പോഴും ഞാൻ പറഞ്ഞ ഓരോ ചാപ്റ്ററും അല്ലെങ്കിൽ ഓരോ യൂണിറ്റ് പറയുമ്പോൾ അതിനകത്ത് റെലവൻ്റ് ആയിട്ടുള്ള ഫോർമുലകളുടെ മിനിമമാണ് അത് നമ്മുടെ കയ്യിലുണ്ടായിരിക്കണം. നിങ്ങൾക്ക് കാണാം അപ്ലിക്കേഷൻ ക്വസ്റ്റ്യൻ വളരെ കുറവാണ്, വളരെ കുറവാണ്. അപ്പോൾ പിന്നെ ഈ ഫോർമുല നേരിട്ട് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക അല്ലെങ്കിൽ അതിനെ എക്സ്പ്ലെയിൻ ചെയ്യുക, കൺസെപ്റ്റ് എക്സ്പ്ലെയിൻ ചെയ്യാനുള്ളതാണ് മെയിനായിട്ട് നമ്മുടെ ക്വസ്റ്റ്യൻസ് കാണാനുള്ളത്. അത് നിർബന്ധമായിട്ടും അറിഞ്ഞിരിക്കണം എന്നുകൂടി ഒരിക്കൽ കൂടി. Now we start with our very first question there. The electromagnetic wave used in LASIK and cell phones are respectively. ലാസിക്കിൽ ഉപയോഗിക്കുന്ന അൾട്രാവയലറ്റ് ലൈറ്റാണ്, കണ്ണിൻ്റെ സർജറിയിലേക്ക് ഉപയോഗിക്കുന്നത് ലേസർ ഫോമിലാന്ന് മാത്രം. അതിലുപയോഗിക്കുന്ന വേവ് അൾട്രാവയലറ്റ് റേസ് ആണ്, ലേസർ ഫോം. അതാണ് കണ്ണിൻ്റെ സർജറിയിൽ ഉപയോഗിക്കുന്ന ലാസിക് സർജറി. പിന്നെ പറഞ്ഞത് സെൽഫോണിലാണ്. സെൽഫോണിൽ ഉള്ളത് റേഡിയോ വേവ്സ് ആണ്, റേഡിയോ വേവ് ഫ്രീക്വൻസി റേഞ്ചാണ്. സോ സ്ട്രൈറ്റ് അവർ നോളജ് ക്വസ്റ്റ്യൻ ആണ്. Ultraviolet rays for LASIK and radio waves for cell phones. So option is equal to box. Now, shall go to our next question. If a ray of light, if air light passes through a medium, its frequency and wavelength are 414 Hz and 450 nanometer respectively, then refractive index of the medium. Now, we have to get the expression for refractive index. And the formula for refractive index is equal to velocity in air, which is a constant for electromagnetic wave, by velocity in a medium. Velocity is in air, refractive index is n. Equal to CA by CM. CA is known to us, 3 into 10 raised to 8. Constant. Now we have to calculate CM, where CM is the velocity in medium, for which is the frequency of the wave and the wavelength in the medium both are given to you. And therefore, CM is given by u lambda. The frequency is 4 into 10 raised to 18. 4 into 10 raised to 14, 14 into wavelength is given 450 nanometer. 450 into 10 raised to minus 9. This one calculation is equal to 1.8. 1.8 into 10 raised to 8. So CM you calculated. Now direct away substitute here. 1.8 into 10 raised to 8. Cancel out. 30 by 18. It's equal to 5 by 3. It's equal to 1.67. So 1.67. That's the refractive index of the medium. We shall go to our next question. The Bohr away lens is -2 diopter. Then type and focal length of the lens. Type indicated by sign with the power. If it is negative, divergent lens or concave lens. First part is over. Now, its power is given 2 diopter. Then what is the focal length? Power is 1 by f. Therefore, f is equal to 1 by p. 1 by power is 2 diopter. Is equal to half meter means 50 centimeter. The answer is in centimeter, therefore half meter is equal to 50 centimeter. That is the focal length. Because it is negative, it is a concave. So concave lens of 50 centimeter. Concave 50 centimeter. So option is box. Next, remember when you speak about power in diopter, the focal length must be represented in meters. Remember. Our next question. In a young double-slit experiment, without varying the distance of the screen and the slit separation, if the wavelength and monochromatic source is changed 1 by 1 in the ratio 2:3:4, then the corresponding fringe width measured will be in the ratio. Now in Young's experiment, in the problem says, we are not changing, we are changing only lambda, everything else remain constant. Then what is the ratio of the bandwidth? Now for which Young's double-slit experiment, you must remember the formula for bandwidth. Bandwidth beta is gone by d by d lambda. This is our formula. Where is the distance from source to the screen? Small d is the distance between the sources, lambda is the wavelength used. Here these are all, these two terms are the constant, no change. Only lambda. The dependence of beta on lambda is by lambda. Beta proportional to lambda. Therefore beta 1 is 2, beta 2 is 2, beta 3 is equal to lambda 1 is 2, lambda 2 is 2, lambda 3. And the lambda 1, lambda 2, lambda 3 ratio given to you 2:3:4. 2:3:4. 2:3:4. That is the answer. And 2, 3, 4. So option is C. So here we mere require the formula for bandwidth and dependence on lambda. Next. Because the following phenomenon does not occur when white light passes through an equilateral prism. Reflection. On the surface there may be reflection. When incident ray on incident partly get reflected, reflection may take place. Refraction, the we under into refraction is denser medium. Dispersion, because of which is a prism, there will be dispersion. Deviation, because it is a prism, there will be deviation. Next, interference, no, there will be no interference. So that phenomenon you cannot expect. Therefore, option is equal to 11. Next. The de Broglie. The de Broglie wavelength associated with the electron accelerated by a potential 81 volt lying in the region of electromagnetic wave. Now, de Broglie wavelength associated with electron accelerated by a potential. Therefore, we have to calculate what is the wavelength of the electromagnetic, de Broglie wavelength associated with this electron, and see which range that wavelength lies, for which we have to evaluate lambda, the de Broglie wavelength. And lambda you have to get in what? Accelerating potential. You know, therefore, lambda, basic formula lambda is h by p, h by mv, h by root of 2me equal to h by root of 2mbq. This is in terms of momentum, velocity, energy, and accelerating potential. Now, in the case of electron, we are given accelerating potential. Therefore, we require this equation. This equation again we can simplify. It can be remembered in the format 12.27 by root v, writing all other terms in the case of electron. And this is the in terms of angstrom. 12.27 by root v angstrom. Is in we have to calculate the value using this relation. We use straight away, remember the relation, start from there. It's equal to 12.27 by root 81, accelerating potential 81. So 12.27 by 9. Definitely, if it is 10, it's equal to 1.2. It's equal to 1.3 something, or slightly greater than or near around. Which I am going to say near around 1.3 angstrom. 1.3 angstrom, which range? Definitely it there lies in the X-ray range. X-ray 0.01 to 10 angstrom. That is the range of X-ray. 0.01 angstrom to 10 angstrom. X-ray range. Here it is near around 1.3, and therefore the wavelength in the range of X-ray. Next one. Question number, next one, the frequency. If the frequency of the incident light on a metal surface is increased by 10%, then the kinetic energy of the emitted photoelectron increased by from 0.5 electron volt to 0.7 electron volt, then for function of the metal. Earlier the frequency is new, then the photoelectric kinetic energy is 0.5 electron volt. Earlier, when frequency was new, the kinetic energy is equal to 0.5 electron volt. Metal is the same, for function is phi. And therefore, by Einstein equation, you can write down H nu is equal to work function plus 0.5. Equation number 1. H nu is equal to work function plus kinetic energy. Now we change the frequency by 10% increase. Because why I say increase? Because increase in the statement. Also it can indicate when you go through the problem, you can see that the kinetic energy increase. Therefore frequency increase definitely. And what is the 10% more mean? If it was 1 nu earlier, second case frequency become 1.1 nu because 10% increment. So therefore the second equation I can write H into 1.1 nu. Frequency 10% more. For function is the metal is the same, phi plus energy is equal to 0.7. Question number 2. And what is asked in the problem? The work function. Work function. And therefore, in the expression, there are two unknowns, nu and phi. Then we have to replace phi, that's okay. We have to retain phi and replace nu. And therefore, if you do H nu is equal to 1.1 H nu. H nu can be written like this, phi plus 0.5. From equation number 1. Substituting for H nu using this relation equal to phi plus 0.7. This is an expansion. 1.15 plus 0.55 equal to 5 plus 0.7. Take this sign, 0.15 is equal to 0.2. So 5 is equal to 0.2 by 0.1 is equal to 2. Is equal to 2 electron volt. Therefore, the option 2 electron volt, option is C. Now the question, the solution bar on the formula, the Einstein photoelectric equation only. Now we shall go to our next question. The total momentum. If the total momentum delivered to a surface by an electromagnetic wave is 3 into 10 raised to minus 4 kilogram meter second, then the total energy transferred to the surface. Now, the question was deleted because of the reason. Total momentum delivered to surface by an electromagnetic wave and total energy transferred to it. Whether it is total energy transferred, whether it is fully absorbed or reflected, it is not clearly stated. If it is the total energy transferred to the surface is fully absorbed, then you know the momentum transferred. Momentum transferred is given by energy transferred by C. This is the momentum formula. Momentum transferred is given by U by C. If it is fully absorbed, if it is reflected, then momentum transferred is equal to U by C. Here it is not stated whether it is fully absorbed or reflected. When you try to transfer the energy, what happened to the photon or energy? അതിനെപ്പറ്റി പറയാത്ത കാരണം കൊണ്ട് ഈ ക്വസ്റ്റ്യൻ ഡിലീറ്റഡ് ആണ്. Now, if it is absorbed, then you can say energy from this energy U is equal to P into C, or 2U is equal to P into C, second case, or energy transferred is equal to PC by 2. Here U is equal to PC if it is absorbed, and if it is reflected, PC by 2. And why the question deleted, I told you. And if it is strictly specified, then you can give the correct answer. We shall go to the next question. The radiation. Oh, again repetition. The radiation used in LASIK is ultraviolet. It is ultraviolet radiation. Earlier coupled with the cell phone, radio waves. Here LASIK alone, ultraviolet. Next, when two coherent sources. When two coherent sources, each of individual intensity I0 interfere, the resultant intensity due to constructive and destructive interference. When individual wave intensity I0, where is the amplitude? When two such wave incident without superposition, the net intensity is I0 plus I0 to I0. This is the total intensity without superposition. Without superposition. Without superposition, the net intensity is 2 I0. If they superpose, then with the interference, net amplitude is A plus A to A. Then intensity is given by I max 2A whole square 4A square 4 I0. With the interference 4 I0. 4 I0 without interference is equal to 2 I0. And what is us? Oh, sorry, question is due to constructive and destructive interference. They are asking about the constructive and destructive interference. So this data is not needed. This data, this relation, this data is not needed. Now, with the interference, constructive interference for I0, destructive I minimum given by A minus A whole square. So it's equal to 4 I0 and 0. So the option is 4 I0 and 0. The option is going to be. Next question. The power. The power of the lens is 4 diopter. Then the lens is. Repetition question. Earlier we met minus. Therefore we told that it's a divergent lens concave. Here is plus. Therefore it's a convex lens. It's a convex lens. Plus mean convex. Part of the answer. In magnitude of focal length, F is given by 1 by P. 1 by 4 diopter. 25 centimeter. So convex lens of focal length 25 centimeter. So option is Next, a single-slit diffraction experiment. The width of the slit and the wavelength of the light used are respectively 5 millimeter and 500 nanometer. If focal length of the lens is 20 centimeter, then size of the central bright fringe will be. Now, in plane wave diffraction, now we are converging the pattern on the screen by means of a converging lens, and there this capital D descend from, this is small a width of the slit, and this is capital D. Here that is equal to F, because we are parallel beam converges by means of focal point by means of a convex lens here. Therefore, this is D is equal to F. Now, question is, what is the width of the central maximum? Width of the half central maxima, beta is equal to D by A lambda. Therefore, the full central width is given by 2 into D by A lambda. So that is our answer. 2 into D by A lambda is equal to 2 into D. So our answer is 2 into D. D is the focal length. Focal length of the lens used given to you. Answer is in meter. And therefore focal length of the lens is equal to 20 centimeter, 0.2. The lambda, the wavelength of the light used in the experiment, is equal to 500 nano. So equal to 500 times 9 by width of the slit is given 5 millimeter, equal to 5 millimeter. 5 into 10 raised to minus 3. This on calculation, this will cancel out. This will become 10 raised to 5. This will become cancel out 10 raised to minus 4. This on cancellation, this is 10 raised to minus 4. Is equal to 0.4 into 10 raised to minus 4, or 4 into 10 raised to minus 5. 4 into 10 raised to minus 5. The answer is not there. The answer is not there in the option. So correct option is equal to this much, 3 meter. Option is not there. Shall we go to our next question? You know, they are asking about size of the central bright fringe will be. Central bright fringe has got twice beta, that is equal to 2 into. Now next question. Suppose they are asking about half the central width. Half of the central band, the answer is there, but the full central bandwidth is not there. Next question. A particle having mass 2,000 times that of an electron travel with the speed, with the velocity thrice that of electron. The ratio of the de Broglie wavelength of the particle to that of electron. You know, de Broglie wavelength of the, in terms of what velocity or speed, lambda is equal to h by mv. Lambda is equal to h by mv. Because in terms of speed, we have to write the expression. In second case, what happens? A particle of a lambda, this of electron, the lambda of particle is going to h by mass of the particle. Mass of the particle is given that 200 times mass of electron. So 2000 m, sorry, 2000 m. And what about speed? Velocity thrice that of the electron, 3v. Is equal to 1 by 6000 into h by mv. But the h by mv from equation number 1 is equal to lambda electron. So lambda of particle equal to 1 by 6000 1000 times mass lambda of electron. So the option is equal to 1 by 6000. So 1 by 6000. Go to our next question. The process by which electron can. The process by which electron can come out of a metal in a spark plug. In spark plug, electric field intensity there is so large. Field ionization, the region ionization take place because electric field intensity is low, so large. The electron come out because the strong electric field is called field emission. So their field emission is taking place. Now option C we go. Field emission, that is there. Electron come out because of the strong electric field existing there. It's called field emission. So field emission. Next. Electromagnetic wave frequency. Now we have to see in which range that frequency lies. Electromagnetic wave, the frequency 5 into 10 raised to 14 Hertz. Straight away, if you remember the frequency order, then this frequency order is in visible light. And therefore, we can say that that is visible region. Instead, if you fail to remember frequency order, then calculate wavelength order. Wavelength order, definitely that is there with you. സാധാരണ നമ്മൾ wavelength order ആണ് classification ഉപയോഗിക്കുക frequency. Lambda value. Lambda value of this radiation we have to calculate. What is lambda value of this radiation? Lambda is given by C by nu. 3 into 10 raised to 8 by frequency is equal to 5 into 10 raised to 40. Equal to 0.6 into this 10 raised to minus 6 is equal to 6000 into 10 raised to minus 10 meter. 6000 meter means 6000 angstrom into 10 raised to minus 10 meter mean definitely this wavelength lie in the visible range and therefore the answer is visible range. ഇപ്പോൾ ഫ്രീക്വൻസിയിലെ അറിയുന്ന ആ റേഞ്ച് ഓർക്കുന്ന ഒരാൾ ഇങ്ങനെ കൺവേർഷൻ ചെയ്ത് നടത്തേണ്ട ആവശ്യം ഇല്ല. അല്ലാത്ത ആൾ വേവ് ലെങ്ത് സാധാരണ വേവ് ആങ്സ്ട്രത്തിൽ ലാംഡയിലാണ് ഓർക്കുക. പല റേഞ്ചുകൾ ഇന്നോട്ട് ഇന്ന റേഞ്ച് 0.01 to 10 ആങ്സ്ട്രം എക്സ്റേസ് less than 0.01 ആങ്സ്ട്രം ഗാമ റേസ്. ഇനി 10 to ഒരു 3500 that is ultraviolet. ഇങ്ങനെയാണ് നമ്മൾ പഠിച്ചു പോകേണ്ടത്. അത് കാരണം കൊണ്ട് നമ്മൾ വേവ് ലെങ്ത്തിലേക്ക് കൺവേർട്ട് ചെയ്തത്. Now next question. Whenever light travels from rarer medium to denser medium, rarer നിന്ന് denser കടക്കുമ്പോൾ, since it is entering into denser medium, definitely angular refraction less than angle of incidence or less than I. Bend it towards the normal. Next, in a denser medium, speed of the light or wave decreases because it's denser medium. Frequency, inherent property of source remains the same. Wavelength decreases. ഇതിൽ പറഞ്ഞ ഡാറ്റ നോക്കുക. Here what is frequency increases? No, remains the same. Wavelength increases, wrong, because here velocity decreases. Frequency decreases, wrong. Wavelength decreases, true. Because the denser medium, velocity decreases. And velocity is given by nu lambda. Velocity decreases, nu remain a constant, therefore lambda decreases. Therefore wavelength decreases. That's the answer. That's the question. Next one. Young double-slit experiment. In young double-slit experiment is carried out by green, red and blue light. One at a time. The fringe width recorded beta G, beta red, beta blue respectively. That's the Mujidana. 2:3:4 എന്ന് പറഞ്ഞ ചോദ്യം. അതേ ചോദ്യം ഇവിടെ വേറെ രീതിയിൽ വെച്ചുകൊണ്ടെന്ന് മാത്രം. Now the experiment setup is the same. You know beta. Bandwidth beta is given by d by d lambda. Since the experiment setup is the same, this is a constant. Beta proportional to lambda. നമ്മൾ ചെയ്തതാണ്. എന്ത് കാണാൻ പറഞ്ഞിട്ടുണ്ട് നമ്മളോട് ആ ഓർഡറിൽ. You know beta proportional lambda. Lambda large, beta large. Out of the largest lambda is for red. Beta red larger than lambda R greater than lambda green greater than lambda blue. Therefore, beta R greater than beta green greater than beta blue. So that is the answer. Beta B less than beta G less than beta. അങ്ങനെയാണ് ഇവിടെ question. Beta B less than beta G less than beta R. The option is equal to dark. Next. The number of de Broglie wave associated with the Bohr atom, a Bohr electron, when it completes one revolution in third orbit. You know, orbit is the path in which integer number of matter wave included, and that is our second law. Angular momentum is an integer multiple h by 2 pi, which indicates that orbit is that path in which when electron revolves, it remains there as a waveform, stationary waveform, so that each orbit include or accommodate integer number of matter wave associated with electron. L lambda. First orbit, 1 lambda. Second orbit, 2 lambda. Third orbit, 3 lambda. Now come to our question. It says that the number of de Broglie associated with the when it complete one revolution in third orbit. In the order of third orbit, 3 lambda. Therefore, the option is equal to box. And this data is there in our second postulate. ഈ പറഞ്ഞത് തന്നെയാണ് സെക്കൻഡ് പോസ്റ്റുലേറ്റ് പറയുന്നത്. ഇൻറ്റിജർ മൾട്ടിപ്പിൾ h by 2 pi എന്ന് പറയുന്നത് ആംഗുലർ മൊമെന്റം. അടുത്ത ചോദ്യം, നെക്സ്റ്റ് വൺ. An electromagnetic wave is propagating. An electromagnetic wave is propagating in a medium with the velocity vi positive x direction. The instantaneous oscillating magnetic field of this electromagnetic wave is along positive z direction. A wave is propagating. Wave is velocity vi means wave is propagating in the positive x direction. Wave is propagating. And the instantaneous oscillating magnetic field of this electromagnetic wave in the z direction. Therefore, B, associated B, the direction of B, oscillating direction of B is positive z direction, BK, positive z direction. Then the direction of the electromagnetic, what is the direction of the oscillating electric field? Question is, what is the direction of electric field vibration? Now, electromagnetic wave propagates so that its velocity direction c is given by E by E cross B. Velocity direction, not c is equal to E by B, c is equal to E by B, but velocity propagation direction. I'm cancelling out this one. Now, wave is propagating and by Poynting vector, the energy propagation direction, that is the wave velocity directed, and that direction is given by E cross B. Basic bond is vector, that is the energy carried per second through unitary intensity of the electromagnetic wave is given by E0 cross B0 by 2 mu 0 or E cross B by mu 0. The amplitude term is the RMS term. That's it. And this is equal to E cross B by mu 0 give the direction of the electromagnetic wave. Or the direction of the energy propagated is given by the direction matralla. This also give you the energy intensity, energy transported per second through unit area. That is what is called Poynting vector. Now, direction E cross B. Now in our problem, E cross B unit vectors associated with E and B give you, after cross production, give the unit vector in the direction of wave propagation, that is called I. Therefore, now I can say I is equal to, that is the direction of the propagation of the wave, is equal to K cross at a unit vector associated with the electric field into unit vector associated with the B on cross production. We must get the propagation direction of the electromagnetic wave, that is equal to Y. What must be this unit vector whose cross product with the K vector give you I. J cross K is equal to I. Therefore, our electric field is along positive J mean positive Y direction. So the electric field is along positive Y direction. Positive Y direction. Remember once again, this is the bond is vector which give you the direction of the intensity or the energy, electromagnetic wave, the energy per second unit area, along with the direction. Direction is given by E cross B. Here we are taking only that part. Direction of the electromagnetic wave is E cross B. That is given as I in the problem. Associated magnetic field is along positive K. Then what must be the direction of associated electric field? That must be J. Yes. Next question. 20. When light is reflected from optically rarer medium, reflected from rarer. Whenever light gets reflected from instead of light, we shall go to our waves, mechanical wave. Rigid boundary, a string tied to one end and a traveling wave reaches here. What happens? You know that the wave reflected with a phase reversal, rigid boundary. But when light incident on a rigid boundary, wave incident on a rigid boundary, there will be reflection. Also, there is a phase reversal. Whereas, on a flexible boundary, when a wave incident on a flexible boundary, there will be, here a wave reaches like this. And returning back, it is like this, so phase reversal. Rigid boundary. On flexible boundary, when a wave incident here, reflect back like this. That means there is no phase reversal. Now come to our light. Rigid boundary analogous to denser medium interface. Flexible boundary means rarer medium interface. When light incident on a rarer medium interface, they are asking, then there will be reflection, but there will be no phase reversal. There will be no phase reversal. Reflection is there, but there will be no phase reversal. What are the... When light is reflected from an optically rarer medium, its phase remains unchanged, but the frequency increases. The phase remains unchanged. There is no phase reversal. That part is true. But frequency increases. Wrong, because the wave is traveling in the same medium. Frequency and the frequency is the property of the source. Whether medium change or not, frequency remains the same. Here velocity remains the same, medium is the same. Frequency is the same because wave is the same. If frequency increases, that statement is wrong. Now box. Both its phase and frequency remain unchanged. True. There is no phase reversal because it is a rarer medium interface. Wave is the same, their frequency remains same. So correct option is equal to box. Whereas if it was a denser medium interface, then the answer. Denser medium interface, then what is the answer? There will be phase reversal. Mean phase differ by pi. Pi, frequency remain the same because wave is the same. Got the point? Here it is rarer. Denser ആയിരുന്നുവെങ്കിൽ ആൻസറിൽ വരുന്ന മാറ്റം ഫേസ് റിവേഴ്സൽ ഉണ്ടാവും. അപ്പോൾ പൈ ഫേസ് ഡിഫറൻസ് ഉണ്ടാവും. പക്ഷേ ഫ്രീക്വൻസി മാറ്റം ഉണ്ടാവില്ല. വെലോസിറ്റി മാറ്റം ഉണ്ടാവില്ല. കാരണം മീഡിയം സെയിം ആണ്, വേവ് സെയിം ആണ്. ഒരു നല്ല ചോദ്യമാണ്. Focal length. Focal length of convex lens of refractive index 1.5 is 3 centimeter. When the lens is immersed in water of refractive index, what is the focal length? In air, focal length is given 3 centimeter. Let's make a formula. 1 by f is equal to n minus 1. 1 by r1 minus 1 by r2. In air. So in air, 1 by 3 is equal to refractive index is 3 by 2. So it's 1.5. Above is equal to 3 by 2 minus 1 into 1 by r1 minus 1 by r2. It's number 1. When it is immersed in a medium, in medium, 1 by f dash is equal to relative refractive index of lens with respect to medium. So 3 by 2 by what is the refractive index of the medium? When lens is immersed in water or 4 by 3 minus 1 into 1 by r1. This is equal to 1 by 2 into 1 by r1 minus 1 by r2. Question number 1. This one calculation is 9 by 8 minus 1. 9 by 8 minus 1 being 1 by 8. Question number 2. Now we have to get what is f dash. So equation number 1 by equation number 2 gives f dash by 3. Equation number 1 by equation number 2. F dash by 3 is equal to equation number 1, 8 by is equal to f dash is equal to 4 into 3. The focal length of that medium and that lens in water become 12 centimeters. Option is C. Option is equal to C. Next question. A narrow single slit width D is illuminated by white light. As the first minima for violet light, lambda is given 4500. Fall at theta is equal to 30. The width of the slit D in microns. 1 micron is given 10⁻⁶ meter. Micrometer. Now, in diffraction minima, what is the formula for diffraction? General formula is sin theta. Yeah. Minima, condition for minima. Sin theta. For first one, n is equal to 1. Where sin theta. 1 into lambda. 1 into lambda. And the question is, what is the width of the slit? So A one, they give the letter D. So okay. But D is equal to D is equal to lambda by sin theta. Lambda is 4000 into 10⁻⁷ meter. Sin theta. Sin theta is equal to sin 30. Minima is obtained at an angle 30. and convert that into micro. Convert that into micro. It's equal to 10 raised to minus 7 upon 0.9 is equal to 0.9. 0.9 micrometer. So again the formula for diffraction minima A sine theta n equal to L lambda. Okay. Go to our next question. The threshold frequency of photoelectric effect from a metal surface corresponds to a wavelength. Lambda 0, lambda 0, threshold frequency of photoelectric from a metal surface corresponds to a wavelength 6000, then the photoelectric work function. Threshold wavelength it is better say. Threshold wavelength is given to you. Then what is the corresponding work function? You know work function y is equal to h nu 0. Hc by lambda 0. Is equal to hc by lambda 0. H value is going to be 0.6. 10 raised to minus 34. 3 into 10 raised to 8 by the wavelength is given to you 6000. Now this on calculation, this on simplification is equal to 3.3. This will cancel out 1.1 into 3 about 3.3 and multiplies all these 3.3 into 10 raised to minus 92. That is the corresponding energy. Next, a proton and photon have same energy. Then the de Broglie wavelength of proton lambda p and wavelength of photon lambda 0 are related. Lambda 0 and lambda of proton. Lambda of proton in terms of energy, because energy is the same, it is said. So you have to write down the lambda in terms of energy. Lambda of a particle in terms of energy is going to by root of 2me, where m is the mass of the particle there, proton. But lambda, this is the basic formula. Therefore, lambda of proton is equal to h by root of 2 into. Now, proportional they are asking. Mass m one there is no proton into energy E, lambda p. Now, in the problem said that there is a photon having same energy. The energy of the photon and energy of the proton and proton, they are the same. Energy of the proton here we wrote down as E, but that is same as energy of the photon. Therefore, given that energy E is equal to energy of the photon, C by lambda 0. Well, lambda 0 the wavelength of the photon, C by lambda 0. So, should here, therefore, lambda P proportional to, they are asking about the proportional relationship. And equal to by a root of 2 into 1 into energy is equal to hc by lambda 0. So goes up. Therefore, lambda proton go into the numerator proportional root lambda 0. And here is in terms of lambda 0 square. So lambda 0 proportional lambda p square. Lambda 0 proportional lambda p square. Lambda 0. So option is equal to dark. Next question. Oscillating magnetic field. Oscillating magnetic field in a plane electromagnetic wave is given by By. It is a progressive wave equation, standard progressive wave equation. Electromagnetic wave, progressive wave. And what is the general formula format? Sine or cos. Ks minus omega t. That is the basic formula. If it is traveling in the positive x direction, if it is negative x direction, then a sine kx plus omega t. Then there is the wave traveling in negative x direction. Now, here the question is not that. Then the wavelength of the electromagnetic wave, they are simply asking about the wavelength of the electromagnetic wave. Now, the equation given to you is this one. But the standard equation is given by V0 sine omega t plus kx. This is the wave equation. This is the wave equation in which the wave is propagating in the negative x direction. And magnetic field along the y direction, y x plane. Next, angular frequency omega, wave vector is equal to k. Now the question is, what is the wavelength of the electromagnetic wave? Wave vector k is equal to 2 pi by lambda. The wavelength of lambda is equal to 2 pi by k. By comparing lambda, sorry. Here lambda is equal to 2 pi by k. Equal to 2 pi by, I'm wrong. 2 pi by k. Lambda is equal to 2 pi by k. Where k is coefficient of x. So k is coefficient of x. 200 pi. Therefore, 200 pi. This will cancel out 1 by 100. Lambda is equal to 1 by 100. Instead of this is in meter. And because the option unit in SI, and this is in meter, therefore centimeter is equal to 1 centimeter. So the answer is equal to 1. We shall go to our next question. Path length. The path length 1 meter in air medium is equal to a path length x meter in a medium. Path length in air and path length of a medium are provided 1.5. Then the value of x. It is given that 1 meter. Now suppose x is the thickness of a medium, whose refractive index is equal to mu. X is the thickness, and this is the geometrical path x. Then the corresponding length, equivalent length in air is called optical path. Optical path. And geometrical path and optical path are related by the relation. Optical path is equal to mu times geometrical path. Now come to our question. This is the formula. In our question is that a path length 1 meter in air, that is optical path, 1 meter, equal to a path length x medium in x meter in medium. That is, this is x, geometrical path in the medium mu. Therefore, x is equal to 1 by mu. 1 by mu. Value of mu is equal to 1.5. Is equal to 1 by 3 by 2. So x is equal to 2 by 3. The geometrical path and optical path. This is the geometrical path. This is the geometrical path. Corresponding optical path is the corresponding length in air. Is obtained by multiplying with the refractive index. Next. So figure is there. A parallel beam. A parallel beam of light is incident from air at an angle alpha on the side PQ of a right-angled prism. Right-angled triangular prism or refractive index mu is equal to root 2, equal to 1.414. The beam of light undergoes total internal reflection in the prism at the face PR. When alpha a minimum PR when alpha has a minimum value of 45 degree, the angle theta of the prism is. Now, figure is given that is here. Now here there is a normal and ray incident at an angle alpha. Before that, we are given the refractive index of the medium n is given 1.414. And therefore, what is the critical angle for this? Critical angle C is given by, sin C is given by 1 by refractive index, 1 by root 2. Therefore, C is equal to 45 degree. The critical angle for this medium, this material is 45 degree. In the problem, now we are going to draw the path. Now it is entering from alpha is given 45. Now it is entering from rarer to denser, bend it towards the normal, go like this. Here if you draw the normal. And if I say, here if it undertake total in the just critical angle, suppose this is the critical angle, the ray just grazes out. If this angle is C, if this angle is less than C, it will emerge out. If this angle is greater than C, it will undergo total internal reflection. That means, strictly speaking, this angle, which I am going to say, is I. This angle I, if C equal to 45, if this angle I is equal to C is equal to 45, it just grazes out. Emergent ray will be there. But in the problem is said that the beam of light undergo total internal reflection. It took that took place, total internal reflection, when light incident on this space PR. Here it must undergo total internal reflection. To have total internal reflection here, definitely I know that this angle I must be greater than C. In our problem, this I is greater than C, that is I greater than alpha 35. നമ്മുടെ ഈ പ്രോബ്ലത്തിലെ ഈ വാല്യൂ 45-നേക്കാളും കൂടുതലാണ്. 45-നേക്കാളും കൂടുതലാണ്. അടുത്ത കാര്യങ്ങൾ നോക്കുക. ഈ ആംഗിൾ കുറഞ്ഞാൽ R വാല്യൂ കുറയും, ഈ വാല്യൂ കുറയും, ഈ വാല്യൂ കുറഞ്ഞു. ഈ വാല്യൂ കുറഞ്ഞു കഴിഞ്ഞാൽ ഡെഫിനറ്റായിട്ട് വാട്ട് അബൌട്ട് ദിസ് ആംഗിൾ, തീറ്റ വാല്യൂ, ഈ ആംഗിൾ കുറഞ്ഞു കഴിഞ്ഞാൽ, ഈ ആംഗിൾ കുറഞ്ഞു കഴിഞ്ഞാൽ തീറ്റ വാല്യൂ കുറയും. തീറ്റ വാല്യൂ കൂടെ എടുക്കും തോറും നോർമലായിട്ടുള്ള ആംഗിൾ കുറഞ്ഞു വരും. എമർജന്റ് റേ ഉണ്ടാവും. ഈ സിറ്റുവേഷനിൽ ഇത് 45 ജസ്റ്റ് ഗ്രേസസ് ഔട്ട്. ഇനി ഇതിലും കൂടിയാൽ, ഇതിലും കൂടണമെങ്കിൽ എന്ത് വേണം എന്ന് നോക്കാം. ഇത് കൂടുതലായിട്ട് ഇങ്ങോട്ട് ചെരിഞ്ഞ് വരണം. ഇങ്ങോട്ട് ചെരിഞ്ഞ് വരുമ്പോൾ 6 കൂടണം. അപ്പോൾ ആൽഫ വാല്യൂ കൂടണം. ഈ വാല്യൂ കൂടിയാൽ 6 കൂടും. 6 കൂടിക്കഴിഞ്ഞ് കഴിഞ്ഞാൽ തീറ്റ വാല്യൂ 6 കൂടിയാൽ, 6 കൂടുന്നവരും കൂടി കൂടുതൽ ചെരിയല്ലേ ചെയ്യണേ. 6 കൂടുമ്പോൾ അങ്ങനെ വരുമ്പോൾ ഈ ആംഗിൾ കൂടുകയാണ് ചെയ്യും. അപ്പോൾ ടോട്ടൽ ഇന്റർണൽ റിഫ്ലക്ഷൻ നടക്കാനുള്ള ചാൻസ് ഉണ്ടാവും. നമുക്ക് കം ടു ദിസ് പോയിന്റ്. വീണ്ടും ഇനി അതിൽ എന്താ ചോദിച്ചത്, നമുക്ക് ദി ആംഗിൾ തീറ്റ മസ്റ്റ് ബി, ആ ആംഗിൾ തീറ്റ എന്തായിരിക്കും. നമ്മളിപ്പോൾ ജസ്റ്റ് ഗ്രേസസ് ഔട്ടിലുള്ള കഥ നോക്കാം. നമുക്ക് what will be the situation now? It is given that this angle is 45 degree. ഇത് തന്നിട്ടുണ്ട്. Refractive index തന്നിട്ടുണ്ട്. അപ്പോൾ ഇതാണ് ആകെ ഒരു application question ഇതുവരെ നമ്മൾ കണ്ടതിലുള്ളതിൽ ഒരെണ്ണം. Then here if we apply Snell's law, sin I by sin 45 by sin R, where this is R, is equal to refractive index 1 by root. Therefore, sin R is equal to sin 41 by root 2. Sorry. Sin A by sin R is equal to root 2. So sin R is equal to sin 45 by root 2. It's equal to 1 by 2. Therefore, R is equal to 30 degree. This angle is equal to 30 degree. This angle, say, critical angle I am saying. If this is C, what about this angle? If this angle is C, then this angle is the 90 degree, the normal ആണ്. This is equal to, this angle is 90 minus, this angle is equal to theta. Then this form a triangle in which this is 30 and this is 90. Altogether this is 90 plus 30, 120. This situation just erases out. No, the 120. Then what you can write? 120. What is the value of theta? Theta is equal to, altogether is 120, 180. All the three angles sum is equal to 180. Then what is theta? Theta is equal to 180 minus sum of these two angles. What is sum of these two angles? 120 minus 120 plus 90 minus C. That is our theta. That is equal to 180 minus 210 plus C. Then what can be the value of C? From here you can see. What can be the value of C? Now what must be the value of C? It is less than 120 no, instead of that is better. Simplify them. Mark here. Question mark. Theta is equal to. We can see that what is the value of theta there is given by. Altogether is 180 minus. This angle is 120. 180 minus 120. Then what about this angle? Minus. This angle we told that if this is 45, it just erases out. What about this angle? This is 45, one is 45. 180 minus of 120 plus 45. If it erases out, this is 45. Then this is also 45. When C is equal to 45, this angle is 45, and therefore the plus 45. Then 180 minus, if it is 45, 165, the difference is If it just grazes out, the angle is equal to 15 degree. 120, 40, degree. Just grazes out. But നമ്മളോട് പറഞ്ഞിട്ടുണ്ട് ഇത് ഗ്രേസ് ഔട്ട് ചെയ്യല്ല. പകരം here it undergoing total internal reflection. Enkil, what about this angle? Greater than 45. If this angle is greater than 45, what about this angle? Less than 45. If this is less than 45, theta will be greater than 50. Greater than 50. Now just grazes out limiting case. Limiting case, we can say that when just grazes out limiting case. Limiting case, what is the value of theta? Theta is equal to 15 degree. Theta is equal to 15 degree. Once again, we first of all we calculated what is the critical angle of this medium. That is 45 degree. And therefore this ray just grazes out if this angle is equal to 45 degree. And if this angle is greater than 45, definitely it will undergo total internal reflection here. About limiting case, if it is 45, if this is 45, this is also 45. This angle is 30 plus 120. 30 plus 90, that is equal to 120. 120 plus 45. 120 plus 45. That angle altogether is 180. 180 minus of this angle. 120 plus 45 is equal to 165. 180 minus 165 is equal to 15 degree. For limiting case, the theta is equal to 15 degree. So that is the answer. It's okay. Next question. The wavelength. The wavelength of de Broglie wave in meter associated with the particle of mass m moving 1/10 the velocity of light is. Now, we have to write down lambda in terms of velocity. Lambda h by mp. Here h by m into velocity is 1/10 that of velocity of light. C by 10. Is equal to 10 h by mc. So the answer is equal to 10 h by mc. That is there. Simply substituting the value of velocity in terms of velocity of light. Now next question. The correct order of arrangement of electromagnetic wave according to their wavelength. Less than idea. And there was the lowest one first. The one which is lowest lambda, gamma rays. Then gamma rays, AM wave, FM wave, microwave. Then if it is gamma rays bus, adil higher wavelength, that is microwave. Adil higher wave, FM radio. Adil lowest ground wave or AM radio waves. So the lowest here is gamma, then micro, in this order, how to do? Then higher wavelength the FM, then longest wavelength the ground wave or AM radio waves. So the option is equal to this. Next question. An ink mark. An ink mark is made on a piece of paper and a glass lamp of thickness T and a refractive index mu is placed on it. If the image of the ink mark appeared to be at a distance x from the top of the surface of the lamp, then the value of x. Now what is x? Here there is a slab and here the ink mark and this is the real depth. Now image is formed somewhere here. And this is the apparent depth. And that apparent depth is us. The question they are asking about that. If the ink mark appears to be at a distance x from the top, This is the ink mark appear to be, and this is the apparent depth, and that is our x. Now you know refractive index is equal to real depth by apparent depth. Therefore, apparent depth is equal to x is equal to real depth by refractive index. Real depth given to you as T. Glass slab of thickness is the T on so T by refractive index here. Or mu is equal to T by mu. T by mu. T by mu. T by mu. So option is equal to box. Next question. All the questions are there, I think. The ratio of amplitude of two light waves. The ratio of the amplitude of two light waves is 2:1. Then the ratio between the intensity of the two waves. They are simply about the amplitude of each wave and asking about their intensity, individual intensity, square of the amplitude. Here I proportional to square of the amplitude. And amplitude are 2:1. Therefore, intensity 2 square is to 1 square. So, intensity ratio is equal to 2 square is to 1 square. 4 is to 1. So, 4 is to 1. So, option is A. 37. Next question is that in Young's double-slit experiment, let me see. In Young double-slit experiment, to change the bandwidth from beta to beta by 4 without changing the experiment setup, the wavelength user must be changed. Again, repetition. Beta, how related down lambda? Beta is equal to d by d lambda. Everything else remains the same. Beta proportional to lambda. Now, beta become beta by 4 when lambda become lambda by 4. That's the answer. Beta become beta by 4 when lambda become lambda by 4. Lambda by 4. So, option is equal to C. Next question. If speed of moving particle. If speed of a moving particle is decreased by 1%, de Broglie wavelength associated is. Now, what about the relation between de Broglie wave and speed? Lambda is equal to h by mc. And therefore, lambda is the function and v is the variable. And the power of the variable is equal to -1. Our lambda function proportional v raised to -1. Therefore, lambda is the function, v is the variable. And the power of the variable is equal to -1, which indicates that when velocity increases, lambda decreases. How much a time? Power times. Power is equal to 1. Variable power is 1. Therefore, what is the variation in function? Variation function is equal to 1%. 1% itself. Because when velocity changes by 1%, നമ്മുടെ basic formula എന്താ? Percentage of error in y is equal to power times percentage of variation in variable. So -1 into 1. So -1%. -1 means എന്താണ് പറഞ്ഞത്? When velocity increases, lambda value decreases. നമുക്ക് ഉത്തരം പറയാം അപ്പോൾ അവിടെ വെച്ചിട്ട്. Here what happened? Velocity. Here the speed of the particle decreases. Here speed decreases. Speed decreases, then lambda value increases. Speed decreases, lambda value increases. How much times? Power times. So increases by 1%. Here speed decreases that, and therefore lambda value increases. How much times? Power times. 1 into power times. 1 into percentage of variation വെലോസിറ്റി തന്നിട്ടുണ്ട് എത്രയാ 1%. 1% ആൻസർ ഇസ് ഔട്ട്. അപ്പോൾ ഇത് ഇവിടുത്തെ ക്വസ്റ്റൻ അല്ല, യൂണിറ്റ് ആൻഡ് ഡയമെൻഷനിൽ പറഞ്ഞ ചോദ്യമായിട്ട് തന്നെ കണ്ടാൽ മതി. നെക്സ്റ്റ്, the photoelectric. The photoelectric work function of a photosensitive metal is 5.2 electron volt. Energy of the incident radiation for which stopping potential is 6 volt. Now you know energy of incident photon H nu is equal to 5 plus EVS, stopping potential. 5 is given to you. The work function 5.2 electron volt plus stopping potential is given to you as 6 volt. So kinetic energy is equal to 6 electron volt. Altogether, important electron. So the energy of the incident radiation should have energy 11.2 electron. Corresponding wavelength they ask about this energy can be converted into lambda. And then the formula 12.4 by energy in electron volt into 1000. That's maxed. This is the wavelength of this radiation used. അത് ചോദിച്ചിട്ടുണ്ടെങ്കിൽ ചോദിച്ചിട്ടില്ല. അടുത്ത ചോദ്യം. Oh, it's okay. Now this is the last question and we completed all the questions from here. Altogether there is 84 questions. Now next class. ഇപ്പോൾ ഇതിനു മുമ്പ് ഇത്രയും ചോദ്യം നമ്മൾ ഡിസ്കസ് ചെയ്തു. ഒരെണ്ണം ഒരു ആപ്ലിക്കേഷൻ ആയുള്ള പ്രസത്തിൻ്റെ കേസിൽ മാത്രം. എനിക്ക് നേരിട്ട് ഫോർമുലകൾ അപ്ലൈ ഇല്ല. Now next unit and the last unit in physics. അതിൽ നമ്മൾ ഇൻക്ലൂഡ് ചെയ്യുക ഇലക്ട്രോൺസ്, ഫോട്ടോൺസ്, atoms, nucleus and semiconductors. Atoms and nucleus and semiconductor physics. So next class we will discuss the question from that unit. Our last unit, unit 8. See you next class. Thank you.